I'm George Hart. I'm a professor at Stony Brook University. I'm a mathematician and a sculptor. I like to design sculptures that show the beauty of mathematics, and I especially love when I can get a group of people to help me build them. I'm here at the school doing a number of workshops with students, getting them to see some of the beauty of math through hands-on activities. One involved taking triangles out of paper and putting them together. We did two versions. First one that's all white, that's a geometry problem, and then one with 5 colors, and the students had to solve the puzzle of how to put them together so every hole had 5 different colors around it. Another activity we did was to take sticks that are skewers and put them together to make what's called a hyperboloid, a shape that you see sometimes in a cooling tower, using little rubber bands, and it makes a beautiful flexible shape. That's just a lovely example of how a curved surface can be made out of straight lines. Another activity we did involved taking CDs, 150 CDs, and joining them with cable ties to make the shape of a soccer ball. As a mathematician, I call it a truncated icosahedron, but it makes a beautiful glittering orb. I did another activity with students in which we took wooden pieces that were laser cut and made a small wooden sculpture to illustrate some of the mathematical principles behind designing a sculpture. And then we did 2 teacher workshops that involve colorful popsicle sticks that go together as a quite challenging puzzle, one involving squares and one involving pentagons that link together in a fascinating way. What I have here is some puzzles that I made using a 3D printer. These puzzles kind of screw together. It looks very easy if I do it, but they can be very challenging. Some people take a half hour, an hour to figure out how they go together. This one here is based on a Menger sponge shape, and the other one's based on a tetrahedron shape. And these are wonderful ways to give people a hands-on kind of aha experience. You can struggle and not solve it and not solve it, and then eventually it comes together. And that feeling of satisfaction that you have when you can solve a puzzle is a wonderful experience that leads people then to challenge themselves with harder and harder puzzles. So I bring these with me for people to play with, and these have been quite popular. So before coming here, I worked with faculty and designed a sculpture of the appropriate size for the space, and I created a file that can be laser cut. We sent that to a local laser cutting company that cut it out of wood that I had specified. So what we're doing right now is we're putting together a large sculpture, almost 2 meters in diameter. This sculpture involves 60 pieces that were laser cut. I worked with students over yesterday and today over several aspects of staining the wood, preparing the pieces, giving them a finish, and today we're assembling them. It's a 2-part process. We first put them together with plastic cable ties, and now we're replacing the plastic cable ties with metal ones that'll be permanent before we hang it up here in the atrium. So this has been really fun. I just enjoyed so much working with all the different students here at different grade levels. I guess the message I would leave people with is to keep understanding that mathematics is a creative, fun subject, that the more mathematics you know, the more power you have to have fun and design and build cool things.